There are 6,728 ways to cover a 6x6 board with dominoes, and every single one of them is secretly cracked. Somewhere a straight line runs clean across the board, cutting through no domino at all, and the whole thing splits in two. That crack has a name. A fault line is a grid line that runs the full width or height of the board without passing through the middle of any domino. Where there's a fault line, the two halves aren't really joined. They just sit next to each other. What we want is a tiling with no fault line anywhere. Every possible cut across or down blocked by at least one domino lying over it. That's called fault-free, and it means the board holds together as one solid piece. For most boards you can do this. A 5x6 board has 6 fault-free tilings, a 6x7 has 124, a 6x8 62, but the 6x6 sitting right between them has 0. Look at that. The board just smaller than it works, the board just bigger works. The 6x6 is boxed in on both sides by boards that manage it, and it alone can't. So this isn't about being too small or too big. Something specific about 6x6 breaks. Try it yourself and you'll feel it. You lay the dominoes down carefully, you get almost all the way there, and every time, one line comes up empty and the board falls open. A computer can grind through all 6,728 and confirm not one works. But that just tells you it's true. I want the reason, the kind you could find with a pencil and never need to check again. Here's the move that cracks it. Stop staring at the dominoes, look at the lines and count how many dominoes cross each one. In this language, a fault line is simple. It's a line that 0 dominoes cross. So fault-free just means every line has at least one domino crossing it. Every line, at least one. Hold on to that. Now, one fact about a single domino, it covers 2 neighboring squares, so it lies across exactly one grid line, the one between those 2 squares. Lay it flat and it crosses a vertical line, stand it up and it crosses a horizontal one. And it can never cross 2, so each domino contributes exactly one crossing to exactly one line. On the 6x6 there are 18 dominoes, 36 squares, 2 each, so there are 18 crossings in total to share out. That's the whole budget. And how many lines are asking for a share? 5 vertical, 5 horizontal, 10 lines, 18 crossings between them. If each line only needed 1 crossing, this would be easy. 18 is plenty for 10. But here's the catch you don't see coming. On this board you can't give a line exactly 1 crossing. It's impossible. That sounds made up. Counting squares to learn something about dominoes feels like a trick. It isn't, and here's exactly why. Pick any one line. It splits the board into 2 pieces. Ignore the rest and just count the squares on the left of it. Some dominoes sit entirely on the left. Each of those covers 2 left squares. 2, 4, 6, however many there are, they cover an even number of squares between them. Always even. The only other dominoes touching the left are the ones crossing the line, and each of those pokes exactly 1 square into the left. So the left squares are an even pile plus 1 more for every crosser. Read that backwards and you get the key. The number of crossers has the same parity as the number of squares on the left. Even squares, even crossers. Odd squares, odd crossers. The squares decide it. So what's on the left of a line in a 6x6? Whichever line you pick, across or down, it slices off a block that's 6 squares along one side. 6 times something is always even. So every line, all 10 of them, has an even number of crossers. Now put it together. Every line has an even number of crossers. 0 is even, and 0 is a fault. To dodge the fault, you need at least 1 crosser. But even and at least 1 means at least 2. Every single line needs 2. 10 lines, 2 crossers each. The board is demanding 20 crossings. And we already counted what it has, 18. 20 needed, 18 owned. It's over budget before you place a single tile. so that's the reason, the whole thing. The 6x6 doesn't fail because you weren't careful or clever enough. It fails because it's two dominoes short of ever holding together. There's no arrangement to find. The crack was always going to be there. Which raises the obvious question. Why do the neighbors get away with it? It comes down to that 6. Both sides even means every line splits off an even block and demands 2, make just one side odd, and some lines only demand 1. Take 5x6, the width is odd now, so the lines cutting across it split off odd blocks, and those only need 1 crosser. Total it up and the board needs exactly 15 crossings and it holds exactly 15 dominoes. It only just fits. Only just fitting is why it has just 6 fault-free tilings. There's no room to spare, every crossing has to land in exactly the right spot and there are only 6 ways to manage that. 6x8, both sides even again, so it's back to 2 per line. It needs 24 crossings and has exactly 24 dominoes. Tight, right to the edge, which leaves it 62 fault-free tilings. Now 6x7, 7 is odd, so some lines drop back to 1 and the demand falls to 19. But the board has 21 dominoes, 2 more than it needs. 2 to spare. And that spare is room to move. Those 2 extra crossings can slide around into different lines and each way of arranging them is a different fault-free tiling. That slack is worth 124 of them, which gives you something that feels backwards. The 6x7 is smaller than the 6x8, 42 squares against 48, and yet it has more fault-free tilings. 124 to 62. Exactly double. Because it was never about size, it's about slack, the gap between what a board demands and what it owns. 6x8 is stretched tight. 6x7 has room to breathe, so the smaller board wins. And the 6x6 is the one board in the whole family where the demand isn't just met tightly, it's more than the board can supply, not stretched thin, actually short. 20 wanted, 18 there. That's why it sits alone. Every board around it is at least tight enough to hold. The 6x6 misses by exactly 2 dominoes it is never going to have. So however you lay them down, the crack is already in the board before you start.